too, right? Do whatever you need to do. All right, so compass directions here. In some cases, you will encounter or you'll be given compass directions. So this is what it looks like. South 30 degrees west. How do you deal with that? Some of you know this already. You've done maybe orienteering, like you've gone through the forest and you need to learn how to do this. So if you did that, then this is going to be easy for you. This essentially gives you the direction of one of the sides of the resulting triangle. It is important to read these carefully since the angles are not always inside the triangle. There it is. Okay, this is on page 59. You should include a compass rose to get you started. Okay, so real quick here, I'm going to use a red pen for my line where I'm actually going. So if you want to do the same, go for it. If you see north 25 degrees west, it is literally saying start north, then turn 25 degrees west. That's what that is saying right there. It's a short little statement, but it actually says that. So it's pronounced, that's how you read it, north 25 degrees west. So I will always say make a dot on your piece of paper and then imagine a compass rose like this. And so in this case, the north is a reference. That's a reference. And so you just go up it a little bit somewhere in here, for example, and then we're going to go 25 degrees west this way, right? And I'm going to use a ruler for this part. You don't have to, but really what this question is saying is that you're headed in that direction, right? So you can put a little arrowhead on your turning point here, right? That you went that way and you moved 25 degrees towards the west. And if it's 25 west, what do we know about this one here? How many degrees would we have to go from west to get to that line? This corner always adds up to 90, right? So that would be 65. So you could have read it the other way, west, right? North 25 degrees west, right? Can also be read as ... Watch what I'm doing here. It's just going to flip it. Look, this west dot back here is going to be up front. And you're going to turn 65 degrees north. Right? So you start west, you turn 65 degrees north. You're still saying the exact same thing. Both ships would have been heading the exact same direction either way. And notice that these always add up to 90, right? Adds up to 90. This is just a check, right? So if they add up to 90 and you just flip-flop the north and the west, you get the same reading. Okay. Let's do this. Let's go arrow that way, and basically 90 minus whatever you had at the beginning, and you're saying the exact same thing. So don't let that throw you off. It's saying the exact same thing. This is says, right? Start west, then turn 65 degrees north. Okay. Both are exactly the same. Gonna do one more. South 15 degrees east. Obviously this is your dot right there, your reference point, but you're saying, hey, which direction am I gonna go on this? So you're gonna go south and then turn 15 degrees east. And make sure it's a small angle because it's only 15 degrees, right? So we're gonna go in that direction. We don't know how far in that direction. That's coming your way yet, by the way. It's like you might say, hey, 5 kilometers in that direction, 5 miles in that direction. But right now, it's just the direction we're interested in. So south, 15 degrees east, could also be read how? Flip-flop, right? Flip-flop. And how many degrees are there here? That'd be 75, right? 75 degrees. So all I do is flip-flop, right? You can say or, okay, that or this. And remember that they always add up to 90. Okay, that's a bit of a check there. So now you know how to work with compass directions. It's not a big deal. Can you put on your study sheet a little compass rose? Because students always mix up east and west. North and south, we're doing pretty good. But east, west, I don't know. It's supposed to say we, not you, right? We, then you got it right. And some of you learned the never eat soggy wieners or something, whatever. Whatever you learned, whatever you do to remember that, I think a little compass rose on your study sheet won't harm you, okay? Let's read it. Let's read a compass direction. So let's say I give you this diagram right here. It's like, hey, give me the compass direction for that one. So you kind of want to see, okay, where is this glued to? That angle is glued to the east line, correct? So you would say east, 32 degrees. Which way are you going from east? You're moving towards south, right? Or you could say south. What is it? 8 gets me to 40, so 58, right? 58 degrees east. Both of them are equivalent. Let's do this one here. Where's that angle glued to? It's glued to north, right? It's touching the north. So you would say north, 71 degrees west, right? Or west, 19 degrees north. But I will do this, if you don't mind me doing that I started with that. That's why the north came there, right? Here, it touched the east. That's why I started with east. So whichever one the angle is touching, that's your go-to, that's your starting point, and then turn towards where the path is pointing. So this is intro to compass directions. Now we can do a word problem. Okay. Can I just look at that box there, the note? When something is southwest or northwest or southeast, that is saying you're exactly at a 45-degree angle. Watch this here, way up here, right? So when it's like that, it doesn't tell you any degrees, but you're assuming that it is 45, right? So it's exactly 45. So it splits that 90 in half, right? So keep that in mind. Come with me to the next page. Let's set this up. Compass direction word problems. And I will tell you this, it's a little heavy on cosine law at first, but it's not always cosine law. It's not always cosine law, right? It's just the way I set it up. I should have mixed it up a bit. But anyways, sketch the following scenarios based on the description, right? So let's say you can see a tree that is due east of you. Very important. Due east means it's directly to the right of you, or right? Sorry, for you, north, west, east. So it would be directly to the left of me. It would be to the right of you, right? That's what it's saying. So you see a tree. So let's set this up. You are here. This is you. And you see a tree directly east of you. This is the tree. And this is also east, right? So it's perfectly lined up. When you see that, that's gold, actually. If something is directly due north or due south or due east, that is actually very important. That helps us big time. And then what does it say? From the same location, you notice that a deer is standing north 40 degrees west of you. So watch what I do here. I go back to where I am, and I should have done that right from the get-go. As soon as you notice these are compass direction questions, this is your north line, right? This one right here, your imaginary north line. And so you're saying that it's, so if this is west here, that means that you're going to go up that dashed line and turn 40 degrees towards the west. 40 degrees right there. And I will use a red one for that one, but it's saying that, right, somewhere in that direction, you notice that there's a tree somewhere here. We don't know how far, but that's a tree. So this is the setup of this question. And naturally, you should notice that you formed a triangle, right? So they could now ask you how, it's not tree, right? It's deer. Sorry. And maybe seeing another tree as well, right? But anyways, in this case, it's a deer. So we have that direction. And so we can now close this triangle, which seems obtuse, right? You can close it and actually start solving for things, right? If you had more information. You don't have a side right now. What's this angle right here? Do you notice that this is a 90 here between the north and the east line forms a 90, and you have another 40 here. So what would this whole angle be right here? Angle Y for you would be 90 plus 40, right? So that's 130 degrees. I'm going to highlight this. I'm going to use orange and just say like this whole thing here is 130. So with little pieces of information that you started to acquire, you start to, hey, I know that whole angle now between the line of sight to the tree and to the deer. I know that's 130 degrees total, right? So you could only assume that this is a 90 because we were told this is directly due east of you. Other than that, we could not have assumed this. The 90 is only true because the north and the east line form a 90, okay? One more, and then we're done. I'm going to stop after this, okay? I promise. Okay? Now we're going to add distance as well, guys. So watch. You travel 12 kilometers in this direction. So this kind of goes together. Okay? Then you turn, very important, you turn and you head north 50 degrees west for 7 kilometers. That's another side of the triangle. How far are you from your starting point? And I'm telling you, you might need some scrap paper, but that's, in this case, I'll just kind of tell you. You're headed northeast kind of direction, so I'm going to start here, somewhere here. This is my start. Compass direction, right? You notice this is not a normal one. There's no angle of depression, elevation, nothing like that. This is compass direction. So you want to do this. You want to make your compass rose like this, and that follows you wherever you go. Okay. So if this is north and this is east, right? That means that we're going north and then we're turning 30 degrees in this case, 30 degrees that way. And we're headed 12 kilometers in that direction. And at this point here, make a dot because you're turning here. Let me put that, label that turn like that. And again, there's a compass direction given. It's north 50 degrees west. So watch this. You make another one of these. It follows you wherever you go. It's like a GPS tracker. It's like, where are you going, right? I'm right. So now this is north and this is west here, right? I'm turning 50 degrees west. So I'm going to go 50, a bit more than 45 to keep it kind of consistent. And you're going 7 kilometers in that direction. Seven kilometers. Guys, can I tell you something? Never assume that, like, some students want to extend this to perfectly line up with the north line of where you started. Don't do that. It's actually safer to assume that that's not happening. So I either go short or I go way past, but I don't line them up perfectly because that makes you think that something is there that isn't. So let's make a dashed line here because this is your end, right? Your final destination. Thank you guys. Have a good long weekend. I'll continue. Okay. So when you sketch this, right, it's very important that, especially when you have a scenario where you travel and then you make a turn, you could be turning any which way. It's important to make sure that the second leg of the trip does not line up perfectly here with the north line, because notice that I will actually make the north line here red. Okay, so remember this. The 30 that you drew helped you determine the direction of the first leg. But in this case, notice that dashed line that I've created. Notice it's cutting that 30. That 30 will not be part of your resulting triangle. And you might be like, well, what's the use of that 30? Well, there is a very important use for it. So watch this. I'm going to make my north-south line in red, and watch this. There's this north-south line here. Remember, that follows you wherever you go. And what do we know about the north-south lines? It doesn't matter where you go, those two lines are parallel, right? So it doesn't matter how far or how close, but we know that they're parallel, which means that this first leg that we traveled, right, is a transversal. Hey, right? So that means that that 30 transferred over, right? Transferred over to here. So if I look at my this diagram, I'm going to take this 30 and transfer it over to here, right? So this 30, let's go, come on, there it is. That 30 will go in here, okay? Alternate interior angles follow. So the 30 is not in this corner of the triangle. The 30 is with respect to the north line and that first leg. So remember, don't transfer it into your triangle. I'm going to make a clean version of this triangle once I've finished everything. Okay. So I will say this, that alternate interior angles are congruent, right? So that's what happened here. So let's make a clean version of that, okay? So if you have a ruler, I'm going to copy that over here. So I always like you to have the interpretation. This is the interpretation, right? The interpretation, then we're going to have a clean version here where we don't have to worry about the north and south lines and all of that, right? So I'm going to try to copy this one. So I'm going to kind of keep that angle and go from here to here. So there we go. Right, that's that side. It's my starting point. And I'm going to try to measure this a little bit. So from the 4, keep that angle as best as you can. Right, that's your turning point. There you go. This is your turning point, and this is your end, final destination, right? So what can be transferred? Well, we can for sure transfer the 12 kilometers and the 7 kilometers. That's a given, right? The 50 is not inside the triangle here, but there's something that you should notice right? We should be able to find this angle here because along the north-south line, we have two angles that are known to us. If we subtract those from 180, because it's a straight angle here, we find the interior there. So that angle right there is 180 minus 50 minus 30. So angle T is 100 degrees. It's very important, right? So this angle is 100 degrees right there. And remember, this 30 is not here. This is not 30 because the 30 was created with the north line and this first leg, right? So it's less than 30. We don't know what it is exactly, so we couldn't use that. Okay. I'm trying to think how I'm going to make this clear, right? So this 30 here, I'm going to maybe turn that blue as well. So notice it was crucial because without that 30 there, we couldn't really figure out what that angle was. We could have figured out like this little sliver here, for sure, that is 40, right? Because we know between the north and the west line, it's 90. So if this is 50, this is 40, but still you have unknowns here. Okay. Regardless of how you do it, because this is 60, right? If this is 30, then this is 60. And if this is 50, this is 40, right? To the west line. So 60 and 40 still add up to 100. So regardless, you get the same answer. Remember, everything is connected. And so now, what do we have? What are they asking us for? It's like, how far are you? Because you started here, travel, turn back east, right? Or sorry, back to your end destination. So how far are you from your starting point? So this is what they're asking for. So this is the clean version of that interpretation. All right, I'd say the biggest problem we have is students wanting to put that 30 in there, and then they also find the 100, so it's 130, that's 50, and that's just not true, right? Or students will bring the 50 over to here, but this is the north-south line would be here, right? So yes, you can bring the 50 in here, but you still are missing that sliver there. So be very careful not to assume things. Remember, you need parallel lines. And so let's see here. This is side angle side, right? That's cosine law for sure. And you'll see a whole bunch of different scenarios, right? So x squared is equal to 12 squared plus 7 squared minus, and you know the drill. Cosine of 100, x would be square root of 222.17. That keeps going. X is equal to 14.91 kilometers. So that's your distance. And it makes sense because this is the biggest side, the longest, biggest angle, sorry, which should have the longest side across from it, right? If you compare to the other numbers. So there you go. Okay, keep going. I want you to actually pause here and try to draw this first. Try to sketch this first. Maybe do it on the side or do it on scrap paper. It is very important that you risk, right? Risk and try your best, right? And then we'll take it from there. So pause it now and try it. Okay, so hopefully you tried this. So let's see what's happening here. The boat leaves the dock in the direction east 40 degrees south for 3 miles. That goes together, right? You have a direction and you have a distance. It turns, right, then is headed east 80 degrees north for 5 miles. That's also important. Determine the direct distance from the dock to the boat's current position. Okay. Okay, so let's see here. I'm going east-south, sort of, right? Like, so I'm going to go starting east and I'm turning south. So I'm going to be going in this general direction. Then you turn, then you go east, but then north, right? So it's kind of like something like this. So it's safe to start here. Okay, so you leave the dock. I don't know, I'm going to call this D for dock. And because there's a direction, I'm going to have my compass goes like this. Okay, and so this is my east line, and I'm going 40 degrees south. So 40 degrees like that. I'm going to use a ruler here, and I'm going 3 miles in that direction. Okay, and then you turn. Okay, so we know that this is 3 miles, and at that point, you're headed east 80 degrees north. So I'm going to make my east line again, and why not the north line? Sure. So your north line is your east line. So you go east and then you turn 80 degrees, which is quite a bit, right? It's 80 degrees like that for 5 miles. So it's longer than this side. What I'm going to do here, and I'd recommend you do that, shoot past where you started. So this would be almost perfectly lined up. I'm going to go past it. And so, I don't know, you can call this C for current position, E for end, it doesn't matter. But here you have your interpretation, right? This is your interpretation. And so, how do we go about this? All right, oh, and this is 5 miles. Should have added that. So, how do we go about that? Well, I would say, sure, close it if you want, but be very careful. Okay, I'm going to close that here, like that. So there's my interpretation. Let's see what I can transfer. This 40 is touching the east line, right? The west-east line, east-west. So that is parallel to the east-west line here. This is west, that's east, right? So we can transfer that over. Why not? This is parallel, that's parallel. We can bring the 40 over to here. 40 right there. You got that figured out? And voila, look at this, right? You've got the 40, you've got the 80 on this side, so it's easy to find that angle here. You would know that this is 10, and this would be 50, right? So 50 and 10, that's 60. We know it's supposed to be 60 there for that whole angle. And what is not happening here? The 40 is not part, so if you redraw this, let's make a copy of it. So I'm going to keep that angle there. So I'm going to bring it here. Try to keep that angle, so you kind of just slide it over like that. There we go. So this is T, C. I'm making it big so that we can have a better visual. So this angle at the turn here, angle T, is 180 again. So it's kind of like the same scenario as before, but this is not going to be the case every single time, right? So this would be 140 minus 80 would get us to 60 degrees, which is already what we expected, right? So this is 60 degrees here, very important. What is not happening is this 40 is not coming in here, because the 40, to be very clear, is between the east and the direction of the first leg of the trip. So there's a little bit left there, which we don't know what it is. And this 80 does not transfer over to C because there's no horizontal line there, right? There's actually no compass direction here, but I mean, you could. Remember, it follows you everywhere. So you could bring the 80 in here and say, hey, this whole thing is 80, but you do not know this angle inside the triangle, so do not transfer that over. So determine the direct distance from the dock to the current position. Same scenario here. This is cosine law again. So we can call it x squared. Let's see here, we forgot to transfer over this from our interpretation. Strongly encourage you to do this, right? To bring stuff, to make a clean version without all the compass roses there. So 3 squared plus 5 squared minus 2 times 3 is 5 times cosine of 60. And so far, they're only one step. scenarios, right? This gives you 19, which in turn gives you 4.36 miles. And I'm expanding this question now. Okay. Now I'm gonna kind of turn it it's like give me a compass direction, right? So state the compass direction from the dock to the boat's current position. In other words, if I were to stand here and I would say, hey, go in this direction, and then you should be able to go straight and end up where you are at the end of your trip. So we basically want to figure out what is this angle here, right? If we knew this angle or this one here, we would be okay, we would be in business, right? So that's what I'm going to do here. I figured that there are many ways of doing this, and I think I will first do it using sine law. So watch what I'm going to do here. I now have a pair, right? So I'm going to use this pair and then use the 5 miles to figure out this angle, the total angle here. Then I'm going to subtract the 40 here, the 40 from it. And that will give me the actual compass direction because I need to have a reference with respect to the east line or the north line, right? To get me there. So I'm going to go sine of 60 over, couldn't you have used cosine law, Mr. Dirksen? Yes, I could have actually, right? Because now you have side, side, side. So go for it. I just want to kind of practice the sine law as well. So this would be 4.36 miles. I'm going to try to keep this short because this is you're doing me a favor here. So sine of D, right? This angle across the side of 5 miles. Let's figure that out. Sine of D is equal to 5 times sine of 60 divided by 4.36. And so angle D is sine inverse of 0.99. That keeps going. Angle D is 83.29 degrees. Okay, oops, can't see that. Just noticed. My bad. And I'm not done yet. 1 second here. Okay, so this is the angle at D. So let me just go back to my diagram. And I'm actually going to go back to the very first one I drew. Okay, the 83.29 is the whole angle here from this leg to the other leg, so it's the whole thing. I'm going to subtract the 40 to get that stretch up there. So maybe let's do this. At that angle D, this is your east line, this is west, right? We know that this angle right here, this is 40. And then we have that other, and because we're not drawing it to scale, it may not look like an 80, right? So we want to know this angle right here. Okay, so we're going to go 83.29 minus 40, which is 43.29 degrees. Okay, so this is now 43.29 with respect to the east line, the east-west line, and altogether it was 83.29, right? So you got to understand what I'm doing here. So in a sense, right, the direction would be east. Let's just round to the nearest whole number. East 43 degrees north, or you flip-flop the north and east, you could say north, because then you're going to go with respect to the north line here. We know that that would be 47 degrees east, right? Both of them are acceptable. So maybe a little challenging, but another way that I'm looking at this here, and I'm trying to figure out if there would have been another way, and I actually don't see it right now. Don't see it. So This is the best way that I know how. Okay, so that's it for this lesson. In terms of what I want you to work on, I'm going to say this is actually a worksheet, Trig Review A. So it goes over everything we've done so far. Solving triangles, just the basic stuff. So if you need more practice, sure, go for it. I left you lots of space there. But if you, what I want you to focus on is the word problem. So page 63, which is question 3, and page 64, that has a compass direction problem right there. So I would say this, solving would be great if you solve it, but I want you to focus on sketching this. How do you sketch it? And then check my key, right? Did I do it properly? And I have a feeling that if once you sketch it and you check, you're gonna want to solve, right? You're gonna be like, oh, now I wonder what it is, right? And so there's a copy of that one. I don't know what happened, page 66. Page 65, interesting. It's a two triangle scenario. Always start with the triangle that gives you the most info and then move over. If you want to try that one, but I'm mostly interested in the word problem. So there's page 67, which has I think that's a sine law scenario. May not be, but anyways, try it. Page 68, which has a speed, right? Speed and time, so that extra added piece there, and it has compass directions as well. So I think I'm going to get you to do everything all the way up to page 69, right? So from page 62 to 69, but I am going to say to focus on the word problems, right? And sorry that I'm dragging this on, but I will also tell you the key will have everything up to question 5, like that worksheet, Trig Review A, and then pages 67 to 69, I'll post them separately because those are other ones that I added to the mix. Okay, have a great weekend. Thank you. See you Monday.